Okay, here we've got another question. It's a normal distribution question. We have got a probability that 18% is a probability, but this time I don't know the mean and I don't know the standard deviation, but in fact I've got two probabilities. This 30% is another one. So this is going to turn into simultaneous equations. So it's about weights of contents of jars. So I know that they are normally distributed, but all I can do is write down mu and sigma squared and say that sigma is, I'm just using the symbol sigma for the standard deviation. Okay, and I've got to then use the given values of 428 and 416 on pictures, and I need to show the 18% and 30%. So as always, I've got my menu of 4 possible pictures. So 1, 2, 3, 4. Okay, we'll call them A, B, C, D as normal. So I want 2 with lines on this side, 2 with lines on this side, shade this, shade this, shade this, shade this. So that's the same 4 pictures we've had, and we need to pick the ones that go with what we're being told. So this one says 18% weigh more than 428 grams. So it's 18%, so it's not A or D. Okay, so which one shows things weighing more than 428 grams? Not this one, that would be less than, so it's picture C for the first one. So for the 428 grams, I need to have this diagram. Z is 0 in the middle. It's like this, so this value of 428 is going to be more than the mean, whatever that is, and I'm going to be expecting a positive Z value. So I can go to my calculator on the distribution mode, so mode 7 for distribution, inverse normal. What probability do I need to look up? Okay, I need the area. This probability here was 18%, 0.18, but remember we always need to work with the probability on the left, so this is going to be 0.82. I've done 1 minus 0.18. So I have to type in that 0.82 here. 0.82 gives me a Z value of 0.915. So that's a Z value of 0.92, which is positive, which is what I expected. Okay, well, let's see what I can do with that Z value. So Z, as always, Z equals x minus mu over sigma. But now sigma and mu are both unknown, so that's going to give me 0.92 equals the x value I do know, it was 428, so that was the actual weight of this jar, but minus mu, which I don't know, divided by sigma, which I don't know. So that's an equation, but unfortunately I can't find mu or sigma from it. I need another equation. So as we said before, this is going to lead to simultaneous equations. So we've done that from the first piece of given information. Let's do the same thing from the second piece of given information. So I know that 30% weigh more than 416 grams. Okay. Well, again, I've got a probability of less than a half, and again the weights are more than the cutoff weight. So in fact, it's another C. Okay, so I can draw a similar diagram again, but now I've got 30% of the weights here, so 0.30. This is still going to be a Z of 0 in the middle. It's still going to be the mean in the middle, whatever the mean might be. And this value here is going to be, this time, 416. So I'm expecting a positive Z value, but because this 416 is less than 428, I'm probably going to get a value of less than 0.92, because this probability is more than the 0.18. So what probability do I need to feed into my calculator? It needs to be the probability on the left. So I do 1 minus 0.30, which gives me 0.70 is the probability my calculator would like to look up. So back to inverse normal distribution, and now I type in 0.70 and find that Z value, and that's a positive Z value, and it's less than 0.92 as I expected, so this is 0.52 as my Z value here. And I'm going to do exactly the same as I did with the other one. I'm going to say Z equals x minus mu over sigma, which gives me this Z value of 0.52 equals this x value, which was 416 minus mu over sigma. And now it's just algebra. So how am I going to get the values of mu and sigma out of these two equations? Let's call them 1 and 2. Well, I've got sigmas on the bottom of fractions, so the first thing to do is to multiply by the sigma to get that out in the open. So I'm going to get 0.92 times sigma equals 428 minus mu, and that follows from equation 1. Equation 1 turns into that. And similarly, equation 2 is going to turn into 0.52 sigma equals 416 minus mu. And now, when this happens, the nice thing is that minus mu, these always match. So I can actually subtract these lines. I've got the same sign, so if I actually subtract these two equations, okay, I can do 0.92 sigma, take away 0.52 sigma, so that's 0.40 sigma. You can do 0.92 minus 0.52 on your calculator if you must. And 428 minus 416 is 12. Okay, and minus mu, take away mu, okay, take away minus mu is actually nothing at all. Okay, we're doing minus mu, and we're taking away minus mu, which is the same as plus mu. So minus mu plus mu vanishes to give 0. That's why I did it. I'm eliminating the mu's. So 0.40 sigma equals 12. So that means sigma is going to be 12 divided by 0.40. Okay. So 12 divided by 0.4 is going to be 30. Okay, 30.0. I've been working to 3 significant figures, and now I've got to use that 30.0 figure in one of my previous equations. I might as well put it into this equation 1. So I'm substituting in sigma equals 30. So I need to do 0.92 times 30.0 equals 428 minus mu. Okay, so on my calculator, I'm going to do 0.92 times 30. So that gives me 27.6. 27.6 equals 428 minus mu. And I've just got to be careful with my algebra here. Now I'm going to add mu to both sides to get 27.6 plus mu equals 428, and then I can take away this 27.6, so mu equals 428 minus 27.6, which is going to be 400.4, or to 3 significant figures it is just going to be 400. So I think I know that mu is 400, and I think I know that sigma from before equals 30, which is suspiciously round values, which makes me think that someone probably made up those values to invent this question. So that's good, we've done it.